sit down a minute?
Oh, no, I'm good.
Yeah.
Thanks,
Yeah. Well, I'm glad we got this many students in 243 this semester. This is fantastic. So, to get back in, so far this week we covered the syllabus, went over just a few back of the envelope house calculations. Started right from energy is power times time. I'm just going to write on this, guys. This is week 1, and I'm only going to give one lecture per week. So here it is. Came up with a reasonable power bill. Looked at our 4.4 hours per day versus a 24-hour day. Did a little bit of across and through variables and a little preview for open circuit voltage and short circuit current. Talked a little bit about the maximum power point tracker. Even did a little physics, photons coming in, bumping electrons up into higher orbitals, heading through the battery, heading to the load, and then back. The particles themselves are immortal, but our technologies aren't. Okay, so let's see what we can't do with week 2 now. That was week 1. Let's see. I will go ahead and make this active. And so week of February 2nd, today's the 2nd, this is Tuesday, so the days match up pretty well. Here's your assignment. So solar radiation, read chapter 2 in PV systems. Exam 2 will cover material from that chapter. Now, I've beaten you to death with this already in 101. So we know that watt is power. We know that a watt hour is energy. And obviously a kilowatt hour is 1,000 times 1 watt hour. No big there. Oh, while I say that, I'm gonna just redo one little problem, and I hope this helps both in 243 and in 214 and all of your courses. And I mentioned this very briefly, but I want to say it again. Whenever you're doing one of these engineering technology problems, you're really doing 3 problems simultaneously. And so let's do it this way, just for fun. Let's take an average load on a house and convert it from kilowatt hours to watt hours, and then also to megajoules. Okay, because there's all kinds of, as you know by now, there's all kinds of ways to measure. There's therms, there's calories, there's BTUs, there's even what in air conditioning there's a thing called a ton, and it's the amount of
ton.
There's a ton. Believe it or not, like a ton is actually a thermal unit. It's the amount of energy required to melt a ton of ice.
Oh, okay.
So.
Well, which ton?
Yeah. So, and in a lot of ways, like that's why I love studying energy, because like it connects everything. But the problem is there's so many dang units, it can be confusing. But let's just go back, and I'll just keep it simple. Let's just go back to our 720 kilowatt hours, and we know this is per month. And I want to convert this to watt hours, which is a problem. This is the problem we're trying to solve. And I'm going to convert it to megajoules, which is another problem that we will soon solve. But what you'll see in each one of these problems, there are 3 problems. The first problem, or issue, that we're dealing with, I'm just going to call this number 1, is that we're running some number through this little machine. The second problem is that we're running a power of 10 through the machine. And let's run it this way. So I just use the the pound sign or the hash sign for number. That's, typically you say number. What's number? That's the pound sign. The 10 means I'm dealing with the power of 10, and then the third one, the problem, is the units. And so there are three different ways to screw up the problem. You can screw up the number, you can screw up the power of 10, or you can screw up the units. But let's just first go from kilowatt hours per month, and I know I want to go to watt hours. Oops. Another thing too, this K should always be a lowercase. Sorry, it doesn't look that way. And this W should always be an uppercase. Sorry, it doesn't look that way. And the H should also be lower. I'll try to do better on that. So what we're trying to get to are just watt hours per month. So start out 720 kilowatt hours per month. And the way I like to do this is with just little boxes. And all I'm doing is multiplying and dividing. Stuff on the top gets multiplied, stuff on the bottom gets divided. I know that I want to keep my months, all right, so here's my months, keep my months. I want to keep my watt hours. There's that, and there's that. The only thing different is this K, right? The only thing different between where I am right now and where I want to go is the K. Now, this K, of 1, 2, or 3, what is the K?
1,000. 2? Oh, I see 1, 2, or 3.
Yeah,
You're asking.
yeah. It's part 2. It's the power of 10. And what we're gonna it's partially the power of 10, but it's also part of problem 1. So we're converting between those two things. So all we need to do is write down basically 1K is equal to 1,000. Pretty simple, right? And that's it. You kind of already knew that from your powers of 10. So from that, what we can do is just straight up algebra, like you've hopefully been working with now. So the 720 and the 1,000 are part of problem 1, so we're just going to multiply those together. 720, 0, 0, 0. Think no problem. The K's, so we've taken care of problem 1. We've taken care of the arithmetic. The K's are going to disappear. We've taken care of our power of 10. So problem 2 is now solved. The only remaining part is to keep track of the units. And that's just watt hours. And then here's months. So that's the answer. So now, as expected, 720,000 watt hours per month is the same as 720 kilowatt hours per month. No big. Okay. Now, guys, I actually have a lunch meeting at noon. I'm already late, but here's what I'd like you to do. Run this little problem on your own. Run, pencil, paper. You can hang out in the class, in my office or go to a different classroom. But run this megajoule problem the same way. And another thing I really want to reiterate here, same thing for 214, is even though the courses are online and you're always dealing with the computer, sit down with your pencil and paper and solve it that way first. You've got that permanent record there. It's always easier to kind of just go back to basics, just, like you learned in elementary school, pencil, paper, write it down. And then if something crashes on the computer, you've still got your notes, and go that way. Okay. So I think we're off to actually a pretty good start. Sorry about the textbook issues. Everything should be ready to go for the solar radiation exam. Starts out kind of easy. So take the week 1 quiz. If you log something into the week 1 forum, I'll take a look at it. Same thing with the week 2 forum, that's right here. So I'll be checking that and getting back to you. So see you in a week. I will have a classroom. We won't meet in my office next week, but thanks a lot.
You just throw it up in the Moodle show or whatever, and you know where we're gonna be.
Yeah, I will. I definitely will, and
Where are you
I'll
gonna put it in the, what is an announcement probably?
I'll email it to you too. I'll get it to you multiple ways. And then also, guys, these 3 lectures will be available. Here's my lunch meeting. These 3 lectures will be available on YouTube, and I'll also be logging on with the Blackboard next week too. Okay, thanks.